Hi friends! In this video we have algebra for secondary 2 and examples on series. A series is the sum of the terms of a sequence, and we use the symbol sigma to write the series in short form. The series A1 plus A2 plus A3 plus AR plus AN. The general term is AR and the last term is AN. AR is an expression that represents each term. The series can be written in the form of sigma from r equals 1 to r equals n of AR. And it means the sum of AR from r equals 1 to r equals n. Example, expand the following series, then find the expansion sum. Sigma from r equals 1 to r equals n of 1 over r plus 1 minus 1 over r. Let's start by expanding the series. Put r equals 1 in the following expression. At r equals 1, so the first term is 1 over 1 plus 1 is 2, so 1 over 2 minus 1 over 1 is 1. So 1 over 2 minus 1, this is the first term of the series. For the second term, put r equals 2. So 1 over 2 plus 1 is 1 over 3 minus 1 over 2. So the second term of the series is 1 over 3 minus 1 over 2. Put r equals 3 at r equals 3. The third term is 1 over 4 minus 1 over 3 and put r equals 4. So the fourth term is 1 over 5 minus 1 over 4. Finally, the nth term is 1 over n plus 1 minus 1 over n. How to find the sum of the expansion? Each term of the series has two fractions. Here we have 1 over 2. In the next term, we have negative 1 over 2. They will cancel each other. Here we have 1 over 3 and the next term has negative 1 over 3. They will cancel each other. Here 1 over 4, the next term we have negative 1 over 4 and they will cancel each other. And so on. All the terms of the series will cancel each other except negative 1 of the first term. What about the last term? We need to find a pattern. The first fraction of the first term cancel the second fraction of the next term. Here, the 1 over 4 cancels the negative 1 over 4 in the next term. So the first fraction of each term cancel the second fraction of the next term. This means that the second fraction of each term will be cancelled. What about the first fraction? To cancel the first fraction of a term, it needs the second fraction of the next term. So to cancel the first fraction of any term, we need a next term. For the last term, it doesn't have a next term. So for the last term, only the second fraction will be cancelled. The first fraction doesn't have a next term to be cancelled. So the two remaining terms of the series are the negative 1 and 1 over n plus 1. Finally, the sum of the expansion equals 1 over n plus 1, the first fraction of the last term, minus 1. Now find a common denominator for this expression. 1 equals n plus 1 over n plus 1. So we have 1 minus bracket n plus 1. Simplify, so we have 1 minus n minus 1 equals negative n over n plus 1. Algebraic properties of summation. The first property, sigma from r equals 1 to r equals n of a constant c equals the constant c times the number of terms n. For example, sigma from r equals 1 to r equals 6 of 4. 4 is a constant number. So sigma from r equals 1 to r equals 6 means the sum of 4 6 times. This means 4 plus 4 plus 4 6 times equals 4 times 6 equals 24. The second property, sigma from r equals 1 to r equals n of c times tr. tr is a sequence and c is a constant. We can put the constant outside the summation notation. So this equals to c times sigma from r equals 1 to r equals n of tr. Another property, sigma from r equals 1 to r equals n of r. This is equal to n times n plus 1 over 2. For example, sigma from r equals 1 to r equals 10 of r. This is equal to, put r equals 1 up to 10 equals 1 plus 2 plus 3 up to 10. Instead of adding all of this, we have a rule. This is equal to n times n plus 1 over 2. n is 10. So 10 times 10 plus 1 over 2, this is equal to 55. The next property, sigma from r equals 1 to r equals n of r squared. This is equal to n times n plus 1 times 2n plus 1 over 6. For example, sigma from r equals 1 to r equals 5 of r squared. This is equal to 1 square plus 2 square plus 3 square plus 4 square plus 5 square. We can get it in one step from the following property. This is equal to n, which is 5 times 5 plus 1 times 2n plus 1 times 2 times 5 plus 1 over 6. This is equal to 55. Finally, the last property, we have TR and ER are two sequences. The sum or difference of two sequences under the same summation notation can be separated under two separate summation notations. So sigma from R equals 1 to n of TR plus or minus ER equals sigma from R equals 1 to R equals n of TR plus or minus sigma from R equals 1 to R equals n of ER. Example, find by two different methods sigma from R equals 1 to 5 of 2R squared minus 3R plus 5. Here we want to solve by two methods. The first is by expanding the series. The second is using the properties of series. And of course, using the calculator is not one of the methods because you have to show your work. First method, by expanding the series. Put r equals 1. So 2 times 1 square minus 3 times 1 plus 5. Then at r equals 2. So 2 times 2 squares minus 3 times 2 plus 5. At r equals 3. So 2 times 3 square minus 3 times 3 plus 5. At r equals 4. 2 times 4 square minus 3 times 4 plus 5. And finally at r equals 5. So 2 times 5 square minus 3 times 5 plus 5. Simplify all of this. This is equal to 90. The second method is by using the properties of series. Sigma from r equals 1 to 5 of 2r squared minus 3r plus 5. The first step is to separate the three terms of the expression into three separate summation notations. The first summation, sigma from r equals 1 to 5 of 2r squared. Put the 2 outside the summation. Sigma from r equals 1 to 5 of r squared. From the properties of summation, this is equal to n times n plus 1 times 2n plus 1 over 6. Put n equals 5, so 5 times 5 plus 1 times 2 times 5 plus 1 over 6. Sigma from r equals 1 to 5 of 3r, put the 3 outside the summation notation, and sigma from r equals 1 to 5 of r from the summation properties equals to n times n plus 1 over 2. N equals 5, so this is equals to negative 3 times 5 times 5 plus 1 over 2. And finally, sigma from r equals 1 to 5 of 5. 5 is a constant, so this is equal to the constant 5 times n, which is 5, so 5 times 5. Simplify, and finally this is equal to 90. Example, write the following series using the summation notation. Here you are given the first 4 terms of a series and the last term, and required to put the series in summation notation, so we need to find the general term as an expression. To find the general term, compare each term to the order of the term, and all the numerators are 1. So compare the denominator of each term by the order of the term to find a rule for the general term. Here we have 5 and the order is 1, so assume 5 times 1. Here we have 10 and the order is 2, so assume 5 times 2. Here 15, so 5 times 3, and here 20, so 5 times 4. It works. Here we have 1 over 50, so 5 times 10. Now it's clear that each term is 1 over 5 times the order of the term, so 1 over 5r. The last denominator is 5 times 10, so n is 10. So the summation notation is sigma from r equals 1 to 10 of 1 over 5r. Another example, here we want to write the following series using summation notation. The first term in the series is 1 times 2 times 3. Second term is 3 times 4 times 5, then 5 times 6 times 7. To find the general term, let's connect each term by the order of the term r. The order of the first term is 1, so assume it's r times r plus 1 times r plus 2. Now check if it works with the second term. The second term starts by 3, while r is 2. So this doesn't work with the second term. So let's try another rule. For the first term, the middle number is 2, while r is 1. For the second term, the middle number is 4, while r is 2. For the third term, r is 3 and the middle number is 6. So the middle number of each term is 2r. Now we need a rule for the first number of each term. Let's compare the first number of each term by the middle number. 1 equals 2 minus 1. And here it's 3. 3 equals 4 minus 1. And here we have 5 and 5 equals 6 minus 1. We can say that the first number of each term equals the middle number minus 1. The middle number is 2r, so let's say 2r minus 1 for the first number of each term. Now let's compare the third number to the middle number. The middle number is 2 and the third is 3, so it's 2 plus 1. Here the middle number is 4 and the third number is 5, so it's 4 plus 1. And here the middle number is 6 and the third number is 7, so it's 6 plus 1. Now it's clear that the third number of each term is the middle term 2r plus 1. This is the rule of the general term. We have 2r minus 1 times 2r times 2r plus 1. The sequence goes forever, so the summation notation is sigma from r equals 1 to infinity of 2r minus 1 times 2r plus 1.